Hello, everyone. First of all, I would like to thank organizers for inviting me today. My name is Yaromir Snechuk from Lviv Polytechnic National University in Ukraine. My co-authors are Kviatoslava Obolyovska and Ivan Kozak. I am going to present you today our research, analysis and comparison of routing and switching processes in campus area networks using CISCO packet tracer. Let's start from the brief look at the subject of our research. The routing process enables exchange of data on a network, and it's one of the most important components that determines network performance. The operation of campus area networks will be analyzed using the routing process at the third network layer of the network architecture and later at the second data link layer. The enchanted interior gateway routing protocol and open shortest path first protocol will be used as network layer routing protocols. The main contributions of these forks can be summarized as follows. Proposing a research methodology for comparing routing and switching processes in campus area networks. Showing that replacing routing using OSPF and EIGRP protocols with layer 2 switching improved the time performance of the investigated network by the amount that depends on the protocol and network configuration. Showing that the effect of replacing routing with layer 2 switching depends on the size of the network. Let's look at how we created our test model. The modeling process and its result will be presented on the example of two campus area networks. A small network, which includes 3 subnets, contains 3 routers and 5 switches, and extended network, in which the number of subnets is doubled and equal to 6. Two scenarios are considered. Scenario A, when subnets are interconnected by routers, and scenario B, when routers are replaced by switches. For scenario A, we will determine the time indicators for dynamic routing protocol EIGRP and OSPF. For scenario B, the time indicators of the switching method will be determined. The time between sending a request and receiving a response, known as round-trip time, is chosen as a time indicator. This allows to determine two-way delays in the route. Solution with the shortest RTT will be considered as the best. Operation of EIGRP and OSPF routing protocols will be alternately examined, providing that IP version 6 protocol is used at network layer. Accordingly, the Internet Control Message Protocol was used to transmit requests to the remote node and receive responses. Let's consider scenario A with the small network. First figure shows structure of small network that combines 3 subnets and contains 3 routers and 5 switches. Second figure shows the round-trip time values for IEGRP, which is 26 milliseconds, and OSPF protocol, which is 22 milliseconds, inside small network. Now let's look at scenario A, but with extended network. First figure shows structure of extended network that combines 6 subnets and contains 6 routers and 6 switches. Second figure shows the round-trip time value for IEGRP and OSPF protocol inside extended network. Round-trip time is configured EIGRP protocol is about 35 milliseconds, and round trip time with configured OSPF protocol is about 25 milliseconds. From described experiments, we can see the impact of routing protocols on the time performance of campus area networks and their dependence on the choice of routing protocol and network size. Main goal is to evaluate the feasibility of using layer 2 switching technology instead of routing technology in campus area networks. Therefore, in the networks that were modeled for RTT estimation, routers will be replaced with layer 2 switches and conduct a similar study. Let's consider scenario B with small network. First figure shows structure of small network formed by replacing 3 routers in the previous network with layer 2 switches. Second figure shows the round trip time values for EIGRP and OSPF protocol and for using switching technology inside small network. Round trip time with configured switches process is about 20 milliseconds. In result, in the network configured with layer 2 switches, the round trip time is less than when using a routing process, 10% with OSPF protocol and 30% with EIGRP. Let's look at scenario B with extended network. First figure shows structure of extended network, formed by replacing 6 routers in the previous network with layer 2 switches. Second figure shows round trip time values for EIGRP and OSPF protocol, and for using switching technology inside extended network. Round trip time with configured switching process is about 22 milliseconds. In result, in network configured with layer 2 switches, the round trip time is 48% less than using EIGRP routing and 13% less than using OSPF. Obtained results for the round trip time values for the EIGRP and OSPF protocols are shown in the table. Let us denote by K the coefficient of increasing RTT when the network dimension increases from small to extended. The summarized results demonstrate the values of this coefficient for all 3 cases. As the network size increases, the RTT also increases, faster for EIGRP and slower for switching case. In conclusion, proposed research methodology allows evaluating and comparison of the time indicators of the network when using routing of the third layer and layer 2 switching of network architecture. The research was conducted using CISCO Packet Tracer Simulator, the Enchanted Interior Gateway Routing Protocol, and Open Shortest Path First Protocol as third layer dynamic routing protocols. Research results have shown that replacing layer 3 routing with layer 2 switching in campus network can significantly improve their performance by reducing package delivery time. That's all for me. Thank you for your attention.